All right, so 1.7, represent functions as graphs. So yesterday we looked at the mapping diagrams, which has the input and the output, and then we talked about domain and range there, and then we had some that were just like tables that didn't specifically say like input, output, or domain and range. It was just an XY table, but we can get all that information from that. So just to see it visually, ways to represent a function. So we can have our mapping diagram, which is what we saw yesterday. So I'm just going to give an example of what that would look like here. So our mapping diagram, we could have, or let's see, we have input and output. And within that, I'm just going to use 1, 2, 3, and 4, and then 1, 3, 5, and 7. So each input has one output, so that would be representing a function. Okay, another way is with the table. So that would be like X and Y, and I'm just going to use the same numbers I used over here. So 1, 2, 3, 4, and 1, 3, 5, 7. And these are just going to be in the table like that. And then the other way we can do it, which is new to what we're doing today, is with a graph. So I'll write that in a different color. So a graph, we would have something like this, and we're going to have 0, 1, 2, 3, 4, 5, and we'll go up to 7 on the way up. 1, 2, 3, 4, 5, 6, 7. So then we just plot each of these points. So the point 1, 1, we go to 1 on the X, up to 1 on the Y, and we plot the point. The point 2, 3, we go X is 2, Y is 3. At 3, we go to X is 3, Y is 5. And then for 4, we've got X is 4 and Y is 7. Okay, and then just those points are just plotted on there. So with the graph, just to give you a little insight to the future of your math career, we have what we call a vertical line test. So how we said that each input can only have one output, that's we're talking about X values. So if at any point as you move your pencil across the page, if there's 2 dots that hit at the same time when you move it across the page, it's not a function. Okay, so it's just another way to look at it. So we're adding the graphing one on today to the mapping diagram and the tables that we did yesterday. But otherwise, we're basically doing the same thing. So these ones, what they want you to do first is they say to graph the function, okay, but you're given an equation and then you're given domain values, which are your X values that you're going to plug in, and then we're going to plot those points, okay? So number 4, Y equals 1/2 X plus 1, and then the values that we're supposed to check are the domain values are 0, 1, 2, 3, 4, and 5. So what I would do is do all the numbers, like do all the solving first and then graph everything at the end. So we're going to put, these are the x values, remember. So we're going to plug 0 in for x, and we're going to solve, and then we're going to go on across the way. So y equals 1/2 times 0 is the first one, plus 1. So what does that equal to?
1.
It's just 1. So then the ordered pair that goes with this, okay, which is the points that we're going to plot, the x value is 0, y value is 1. So I would just write that to the side so that when we go to graph it, you'll have all your ordered pairs stacked nicely together. So then we're going to plug in 1 for x, so y equals 1/2 times 1 plus 1, which is what?
2.
A little bit less than that. What's 1/2 times 1?
1/2.
So then 1/2 plus 1 is what?
1
Yep. So 1 and 1/2. And since you're graphing, I would say leave them as mixed numbers, but whatever you're feeling, I don't care. So x value is 1, y value is 1 and 1/2. So then let's do 2. So y equals 1/2 times x is 2 plus 1. Let me rewrite this so it's a little easier to see. So what is 1/2 times 2?
4.
So this would be like, let me rewrite this a little bit better. If you have 2 halves, how much do you have? If I give you 2 halves of a cookie, how much do you have? Like how much total cookie do you have?
2 over 4.
So what we can do when we're doing this is these actually can cancel. So it'll just be 1 plus 1. So then it's 2 total. So we have the point 2, 2. The good news is this is the only one with fractions. So we're getting out of the way now. All right, so then we're going to do it for 3. So y equals 1/2 times 3 plus 1. So this one is going to be 3 over 2 plus 1. So that's going to be, where is it? 3 over 2 plus 1. So then I can rewrite 1 as 2 over 2. So I'm going to get rid of this and rewrite it that way. So I have a common denominator that I can add them together now. So that's going to be 5 over 2, which is what is a mixed number? How many times can 2 go into 5? 2 times, and then I'll have like the one thing left over, so it'll be 2 and 1/2. So this ordered pair will be 3 and, where is it, 2.5. So then the next one, we're plugging in 4. So y equals 1/2 times 4 plus 1. So what is half of 4?
2.
2 plus 1 is 3. So then this ordered pair is going to be 4, 3. And then the last one, we're plugging in 5. So y equals 1/2 times, whoops, not 1/5, 1/2 times 5 plus 1. So that's going to be 5/2 plus 1. Since it's a 2 on the bottom, I'm going to rewrite the 1 as 2/2, which is going to be 7/2. And then how many times does 2 go into 7? 3, and then we'll have 1/2 left over. So 3 and 1/2. So then this ordered pair is going to be 5, and then 3.5. So then we're going to put each of these points on a graph. So I'm just going to do it up here. So my x values are from 0 to 5, so I need to go all the way out to 5. So 1, 2, 3, 4, 5. And then my y values, the biggest one I have is 3.5, so I'm going to go up to 4. 1, 2, 3, 4. And then we're just going to plot the points on the graph. So the first one, x is 0, y is 1. So that's going to be right here. The next one, x is 1, y is 1 and 1/2. That's here. Next one is x is 2, y is 2. Then x is 3, y is 2.5. The next one, x is 4, y is 3. And the last one, x is 5, y is 3.5. So it should look kind of like a line there, more or less. All right, let's do another one. Let's do number 6. Y equals 3x minus 1. And the domain is, our x values that we're plugging in are going to be 1, 2, 3, 4, and 5. So this one's nicer. It doesn't give us fractions. So I'm going to start with 1, and I'm going to work all the problems down, and then we'll graph it again like we just did on that last one. So y equals 3 times x is 1 minus 1. So what does that equal to? 2. So then that's going to give us the point 1, 2. We're going to plug in 2. So y equals 3 times 2 minus 1. What is that one going to be? 5. So this point is 2, 5. Next one, we're plugging in 3. So y equals 3 times 3 minus 1. 8. So that's the point 3, 8. Y equals 3 times 4 minus 1.
11.
So that's the point 4, 11. And then the last one, 5, 3 times 5 minus 1. 14. So that's going to be the point 5 and 14. So So now I can graph them. So since my y values go up to 14, I think I'm going to count by 2's going up just so my graph's not huge. So on the bottom, I'm going to count by 1 still. 1, 2, 3, 4, 5. And then on the other side, I'm going to count by 2's. So 2, 4, 6, 8, 10, 12, 14, 16. And then we're just going to graph each point. And I tell my other classes I don't get out like a ruler and measure that they're exactly right, so don't feel like they have to be perfect or anything. So first point, x is 1, y is 2. Then x is 2, y is 5. X is 3, y is 8. X is 4, y is 11. And then x is 5, y is 14. And so then you have your graph. So that's really all we're going to do with this section. Y'all feel okay with this? Just plugging in the numbers and then plotting the points. So, like I said, this is just a really short section. And the rest of it we just really don't need to look at. So, I'm just going to have you guys do 3, 5, and 7. And none of those have decimals or fractions. So, they're not too bad. The ones with fractions are a little bit rough as they give you, massive numbers to work with. So.